Hi, this is Vinod Suman. Today I'm going to talk on TensorFlow, and I will give some basic foundation. What is a TensorFlow, how to use, and what are the important concepts for the TensorFlow. So let me start this session. So what is the TensorFlow? If you want to say in a very nutshell, TensorFlow is a software framework that help you building and deploying the machine learning model. So, and good thing is that no need to pay anything for the TensorFlow. This is free license, and TensorFlow gives the basic building block that is required for you to design and train and deploy the machine learning models. And it is very flexible enough, and we can use the TensorFlow in for the several different type of machine learning algorithms, but it's typically more useful in the deep learning network. And deep learning network built with the TensorFlow are used in many different areas, like the image recognition. You have the one image, and you want to check the similar kind of image, and the speech recognition, whether you can turn your speech into the text. So what is the definition actually? What is the TensorFlow? TensorFlow is the open source software that is released in 2015 by the Google, and it's make the developer very easy if they want to design, build, or train the machine learning model, particular for in the deep learning case. They use computation power, and it is written in the C++, but a good thing if you use in the Python is very easy. And the important thing of the TensorFlow is that this is the computation graph of data flow. So anything the TensorFlow is, you have to make the graph, you have to create the node and edge, and then you have to pass those graphs into the session to finally execute it with the C actor. And if you see this very simple node or graph, this node represents any mathematical operation, like the addition, subtraction, multiplication, or any kind of the mathematical operation required for creating the model data machine learning model. And this edge represents how the data flows from one node to another node, and this is the input data in the form of the x and y, and all the data in the TensorFlow is represented as a tensor. So tensor, what is a tensor actually? Tensor is a multi-dimensional array. So if you see the tensor actually, you can see this is the multi-dimensional array of the numbers. It could be the scalar, it could be the vector, it could be the matrix. But anything, even this is the individual number or the array or the matrix, it is the tensor in the context of the TensorFlow, and why it is called the TensorFlow. And having said that, we have to create some graph that should be executed inside the session of the TensorFlow. So this is the graph. For the example here, you can see we are passing the two data, and they are going to add, multiply on that multiplication, another number we are going to add. So you have to create one graph. Once you create the graph, you have to put into the session, and this is the lazy loading. So the moment you add W and the X, it is not going to execute until unless it is you are not giving the complete graph inside the session. So how it works actually is the So if you go deep inside the TensorFlow, let me explain some alternatives of the TensorFlow. What is in the market right now? So we have the torch, and that is written into the Lua. This is a similar kind of Python scripting language, but it's is very less commonly used outside the deep learning community. And if you want to use the torch, again you have to study a complete new things, the Lua language. So most of people, if they have already knowledge in the Python, they actually stick with the TensorFlow. Now the competition between the TensorFlow and the Thino, both are the similar kind of things, but the Thino, it has the additional steps, that is the graph comparison steps, and they took the significant time while creating the model, and they reduce the time while the doing the training time. but for the graphics comparison, they took the huge time. In the case of the TensorFlow, it is the much cleaner interface compared to the Thino, and it was built with the production in the mind. Actually, Thino is more go for the research purpose and all those things, but the TensorFlow has been created, keeping the mind it is going for the production or the actual work. And fourth is the Keras. Keras, before talking about the Keras, I will say about TensorFlow. TensorFlow is the rollable toolkit. Means you have to write the right, number of lines of code to achieve some your computation or create the model. So you have to write very low level. You have to go the low level to write a lot of things to create or design the models. But in the case of the Keras, it is the Keras is the very high level programming toolkits, and it's make the developer life easy, and you can do the same kind of things in the Keras, very few line of codes. So so it is more popular wrapper. It is wrapper on the TensorFlow. Internally, if you see the Keras use the internally they use the TensorFlow. So my recommendation is that first you should learn the TensorFlow, then you will come to know a lot of internal things. Once you become the master or the good hands-on, then you should move into the Keras to make your life easy. So first thing first, how we should install the TensorFlow. If you have already working on the Python, so it's very easy. You go and type the command Python install TensorFlow with the pipe, pipe. And I hope you must know about what the pipe works and all those things. Now, the important thing is that TensorFlow come into the two flavors, one with the CPU and the one GPU. So because if you see the neural network, we need a lot of computations, I think, and they need the huge computation power. So before these things, why you use the deep learning? Because we have to work for the image recognition, speech, and all those things, and the input parameter is very huge for the any image or the speech. So that's why, and they have the multiple hidden layers. So we have to, or the logic pass from one layer to another layer. It consumes a lot of computation problems. It requires a lot of computation power. So that's why TensorFlow come to the two favor, either on the CPU or the GPU. If you take the GPU, they will utilize your GPU power to do the computation. And but if you want to install the GPU enabled version, you have to take some extra steps. But I'm going to just this is a very basic session for the TensorFlow. So I'm going to teach on the simple installation for the TensorFlow. So how to start the TensorFlow things? So for that, you to the command line. I'm going to command line and give the command. I'm giving the path where you have used. So I have already installed the TensorFlow. I'm going to use the Jupyter Notebook where I will use the command for the TensorFlow. And I'm going to use the start the Jupyter Notebook, and I'm also going to start the tensor board. I will talk on the tensor board. Tensor board actually, as I explained, that TensorFlow works on the graphical computation thing. So to the tensor board, you can see all the graph, all the input, how it is computing everything. So it will explain in a very easy way, because down the line you might have very complex graph, not able to understand the code. So this tensor board will give a very good representation of your mathematical graph into the pictorial format. So let me start from the hello world things. So I have already code here with me. So yeah. So then again, I will come into the my PPT, how it works. So first, what we have to do, you have to create the TensorFlow object here, TF, and we have to create one constant, and that constant I will pass the hello, and another constant I will pass the tensor. So this is the first node, and this is the second node, and both node I am going to add first and second. I will get the this full node. Full word, and I'll be trying to print it. But if you try to print this, you will not get your expected output hello words, because I says uh, up to here we have just created the graph. Now you have to pass those graph into the TensorFlow session to actually execute it. Let me see how you should do that. So first you have to import the TensorFlow as a TF. So I'm using the TensorFlow version is 190. And if you see the, I create one constant hello, and the second is the hello world. But and in the, this is the one node, first and second node, second. Now I'm going to making the bridge to connect both node using the third node. This is the third node full word. So now if I'm trying to output the full word, I'm not going to getting the expected output hello tensor. So for that you have to create some session, because explain this is TensorFlow is the complete graph edge-based computation philosophy. So once first you have to create the node, you have to connect the node and make one graph, and you have to pass the graph to the session. So here I'm creating one session. If you see tf dot sessions, so tf object I imported from the TensorFlow, and it has the session object, and creating one variables putting to the sys. And now I'm running the actual this forward. So, and I will talk about this. So now if you execute, and now if you see the output, you can see the output hello tensor. So this is how it works. So as I said, we have the concept of the tensor board where you can see all those things. So I have already started this the tensor board. It works on the 6006 port. So let me put my machine name in the port 6006. 6006. So you can see the graph. So this is the graph actually. So we put that two numbers and add, you can see. So let me create some good graph, and I will show you. It is very good to see here. And you see the notice here, B is going to be showing the byte. If you don't want to see the byte, so you just do the result.decode, it will show the string here. So if you see the tensor code, we have these things, and yeah, it was a basic thing. Getting back to my presentation. So as I explained, what is the actually no, I don't want this one. I want to maximize it. Okay. So the I explained that why the session is very important in the TensorFlow. So and let me create one this kind of graphs. So what I will
Sorry, I'm not sure.
Why my Alexa is talking? Okay, so I take the constant 5 into the A, and constant 7 into the B, and constant C 10. So this is the three node A, B, C. Now we are trying to multiply A and B, and the data will go to the answer will go to the D. Then I do the again add B and C, put into the E, and then the F, and subtract. So I have the this graph, and if you see in session, I'm just passing the F. F is my the final things, and if you see the F, it is starting with the subtract. And if you execute this command, you will get the output, and you will get this kind of graph. So let me explain how this graph is showing here. So this is the subtraction. So you take the last operator. This was the subtractions. So two value was coming, D and E. So this is the two value is coming here. And for this E also we have the add B and C. So this is the add, we have add two value here. And for the D also we have the multiply of the two. So you can see the multiplication. So in this way you can see the computations into the picture format. Some important concept into the TensorFlow is the fetch. So now you got the output, final output 18 here. So if you want to see all the intermediate values, you can use the fetches. So if you use the fetches, let me see here. So yeah, fetches. So if you run this, you will get, okay. So what it F Oh, I have not executed this part. So let me execute this part and I will get the output. Now if you execute this fetch, you will see all the output, intermediate output. So all this the fetches work. So now if you see the fetches, no data type. So by default, if you pass the numbers depending upon the data, they will define the data type internally automatically. But on top of that, if you want to define your data type, you can also do that. In this case, if you see, I pass the constant 57 and I want to check the data type. The method is the D type. If you do the D type, it will show the data type. So it is considered the integer 32 bits. And if I put the 0, it will consider for the float number. If you put the 57.0. And but if you want to make the C variable 57 on the float 64, so you can pass the extra parameter, your data type. So it will work like that. So in this case, if you see, I have the pass this one on 64, so taking the 64. And the second concept comes the array and the shape. Shape is the dimensional shape if you have the 2D with the number of rows in the columns. So we can define like this. Constant, you pass the all the vectors. This is the single array. If you want to 2D, you have to pass into the double quote, double brackets. Become these things. But let me show here. So this is the C. And again, if you want to print the C, you can't print. Let me see here. If you want to see the print, it will not show the data. So as I said, if you want to see what you have to do, you have to do the with the df dot session in the sys. But for the time being, that is not a good practice. But I am doing here df dot session, and then output of the run. We want to run the C, and then we will see the output of the C out. So now it will show the 1, 2, 3, whatever here. And the same way we can make the 2D dimension array with the constant. And if you want to see this D, again you have to pass through the session. It become it will show the data. And the third is that you can use also the numpy. If you have the data array in the numpy, you can create in the numpy, you can pass into the TensorFlow. It works. So let me show the example. So see here I import the numpy np and I create the array and e, and e I am passing into the TensorFlow constant here. You can see. And the same way, if you want to see, you can see the data. This was all about the arrays and the shapes. What I'm talking about when you start the actual problems, when you create the model, regression model, so immediately you have to do, you need all those operations. So these are the very basic building blocks for the TensorFlow. And the sequence, suppose if you want to generate the sequence, so how you do that. So if you have done in the numpy, you have used the same line space kind of things, you can use the same thing here also. TensorFlow line space, start from 2 ending 10, I want 20 numbers. So all the sequence will be getting to the D, and if you pass the D, you can see all the numbers. This is the one way. And second way, if you want to fill all the matrix with the same number. So in this case, I'm creating the matrix of the 4 into 5, and I want to set all the data with the 100. So use the field, and you might get the same command in the numpy also. So with the field 0 and all those things, I will show you. So here, if you now output is the complete all the matrix with the 4 into 5 matrix with the 0. So the same code here I have made here. Let me execute for that and for this number. So no, I don't want 200. I want to suppose the anything 99. So you execute it, you will get 99. And now the important thing is the variables. So these variables is a bit different from the actual normal variables what we used to do actually. These TensorFlow variables are in the memory buffer that contain the tensor. And you know, I have already explained the tensor, what is this multidimensional array. It could be the scalar, vector, and the matrix. And but unlike the normal tensor, it instead when the graph is run and immediately wipe out afterwards. So it will not create the variable until unless you have not started your graph into the inside the session. And once you start the graph, then it will initiate. And after the session finish, it will also wipe out because the data is used, and this is the memory cost of the memory. So there are three important properties for the TensorFlow variables. So variable must be explicitly initialized before a graph is for the first time. I will show in the code why it is important. And second thing, we can use the gradient method to modify variable after each iterations. So if you see the concept of the deep learning, we used to do the on the every layers we calculate the logic, we pass into to the activation function, we pass into the other layers. At the end, we have to actually tuning of the weight, tuning. We have to do the tuning for the weight and the bias. First, you have to start with the randomly initialize the weight and bias, but at the end, you have to do tuning for your weight and the bias, and that we use the gradient descent backbart propagations. So through the backbart, we do change the weight, and again go at the end. I can do the forward propagations until we get the almost the correct answers. So for that, this variable is very required that time. So you have to always changing for the each iterations. You have to change those values. So it's very useful the variables for that calculations. And we can save the value store to the disk if it is required. So there are many ways to create the variables. One is the variables tf dot variable. You pass the file. Optional, you can pass the name also. This is one way. Another way is that you generate some random number and you pass those random numbers into the variables. So how it works, I want to show here. So see, suppose I create the variable 10 and the 20ab, and I third node is the a plus b, and I want to see here. You can't see, so because we have to pass into the session. So now even I create the session, that is not the good way. You always use the with a tf dot session and the edge session and run that. So now if you run this, it is giving the error. Because as I having said that variable must be initialized. So suppose if you have the five variables, all those pipes must be initialized before executing inside the session. We have not initialized the variables, that's why I'm getting this error. So how we can initialize? The way is that you do the tf.global variable initializer. What it will do? All the variables by default initialize with this method. So now I initialize. In the session, we have to pass this init, which will initialize all the variables. Then we can run, pass the final graph, and print. Now you can see I'm getting the answer. This is the one way. And suppose if you have the 10 variables, you don't want to initialize all the values. You want to go the particular variables you want to initialize. So other way is that you go session, no need to call the global variables. For the particular, you go session a dot initializer, b dot initializer. Which variable you want to initialize, you can do here. And these are the variables. And the other way is that you create the random number and pass into the variables. This is also a way. Let me execute this code, and you can see all the random number. Matrix size is the 300 into 200. So a number between the 0 to 1. So this is the way. And the other way to generate the create the variables, directly you can pass the random number, and it will also the create the variables itself. And to consume this, again you have to use the global variables. So this is the variables, very nice concept and very useful, handy weapon when you do create your model in the deep learning. And the other way, as I explained, you can do the tf.0. So if you it will fill with the zeros, ones, the field. I explained all the fields, random number, different uniform distributions. All those way you can do that. These are the operations you can do on the your TensorFlow node: add, subtraction, multiplication, divisions, greater, less, equal, and all the matrix operation, array operation, checkpoint operations, control, merge, switch. You can do. These are the very useful when you do actual required for the model building. Phase order. This is also an important thing. Phase order means you just create one place without passing any data, and during the runtime we can use this placeholder passing those data during the runtime. So suppose when you do the linear regression or some kind of things, you have to pass the logic from one to another layers. So every time you need the new data, you suppose you have the 10,000 inputs. So you will not take all the 10,000 input together. So what you will do the batch wise. So every batch wise you will take and do the manipulation. So for that batch wise data, you need some placeholder. So we can keep those data. That's where this placeholder is required. And so because variable is insufficient, because that we have to mean to initialize once you initialize, it will not changing always, right? So, and you have to initialize before we starting the work also, but in the placeholder I need some data is runtime, so that's why this placeholder is required. And so if I want to see the code, placeholder code, this is the placeholder code. So if you see, I tf.placeholder, I need initialize. See, I'm not passing any data here. I just a placeholder ph, and I did the multiply with the ph and 2. Still, which number 2 is going to multiply, I don't know. I will pass this number during the runtime. Now I start the session and see the beautiful here. Session.run. I'm passing the D is the variable, but with the D I have to also pass what is the value of the placeholder. That is a part of that graph. So now I'm saying feed dict th is equal to 5. So now I pass the 5 and into 2 results with the 10. Next time you use the same placeholder and pass the 50 and 500, you will see the output. So this is the placeholder. So it was all about the basic of the TensorFlow. So I'm going to show one the important exercise, how you can do the linear regression in the TensorFlow. In this short, I'm going to explain. We will import the NumPy and the TensorFlow, as I explained you, and I will take the sample 10,000. I will tell you why. And for this sample, I create one tensor with the between the number of 0 to 10, and I want to create the 10,000 sample. So now X has the that having the 10,000 numbers between the 0 to 10. So thing is that what I'm trying to do here, this is the my linear regression. Y is equal to 2x plus 5. So if you see the model, it's actually y is equal to ax plus b. And if you see, b is the intercept and x is the slope here, and x is the input and a is the slope, if you see. And so actually I'm going to predict this output. Means, I'm showing here, but I want to check how I'm getting the same data from my model. So a value should become the 2 and the b value should become the 5. So how it will work? First, we have to create the two variables. The purpose for this exercise is I want to use all those building block here, so give the better understanding. So now I create the two variables a and b, what I have to predict and b, and passing the simple one is very simple one data actually, and create the two placeholder. Why it is required? Because I'm for each base I am passing the different data, input data and the target data. So I create one placeholder for the data, one placeholder for the target. So I'm passing here none. It could be anything. So I'm just passing the none and the data type also. And now I'm getting. I'm going to output of the one layer to another layer. So what I'm doing, you know, in deep learning you have to take all the input, take one input, weight, multiply the summation of all this node, and then add the bias. So if I did here, so I did the TF multiply between this, and then I will going to add. So in this X data, we might have the many, not one, and then the by B. And in this case, A is the weight here, and the B is the bias. Now, actually, you have to find out the loss. So loss actually it is calculated by the square root of the difference of those data X and Y, the difference between the actual and the computed data. But instead of the square root, it will give the same answer if you do just the half of the reduced sums. If you can use this formula for that. and then learning rate. So what the learning rate is here. So when you do the gradient descent, we have to set the learning rate, because suppose you have the hyperpolar graph is there. So what speed they will change that the slope, find the minimum slope. So that's why we set the learning rate here, and TF trend, gradient descent, and learning rate. Now I got the GD, and you can use the GD to find out the loss. So, and this is the code here. Let me show the code in very short. This is the TensorFlow Regression. If you see, so I take 100 sample. I explain everything. Let me just run those steps. So now we have to predict our weight and the bias. So explain here, and we have the training process. Now we got the training process. What actually happened in this training process? Loss is not defined. No, I didn't execute this one, I think. Yeah. Yeah. So now the my turning things. What I did here, if you see, I initialize for the A and P what I have to predict from the each session, and I have to range for the 5,000. So I will do this repetition for the 5,000 times, and each time I'm getting the here. If you see the random, I choose the best size. Best size I have defined the 100. So I will do the 5,000 iteration, but each iteration I'm getting the 100 data from the input. From that from my training data, and I have the training data and the target data, and the passing the, and here you can see the placeholder use, how I have used this placeholder, passing this data, and then compute the loss. So let me execute these things. So it is coming, see, so it is coming. It starts from the 1.3 and the -1.1. Finally, it becomes the 2. This is the, if you see the 2 here, same weight 2, and the bias is equal to almost 5. So this was the basic thing of the TensorFlow, and thank you very much for this watching, and happy learning. Thank you.